In our second example, we're asked to show that the ABCD is a trapezoid and then decide if it's isosceles or not. And for it to be a trapezoid, we have to have two parallel bases. So parallel lines have the same slope. So a couple of ways that we can approach slope. We can say that the slope is y2 minus y1, the rise, over x2 minus x1. Or if we have it graphed, we can simply count the rise and run. We're rising 1, running 1, rising 1, running 1, rising 1, running 1, or rising 3 and running 3. So our slope for line AB is 1. For CD, we're rising 1, running 1, rising 1, running 1, rising 1, running 1, rising 1, running 1, or rising 4 and running 4. So our slope of CD is also 1. So yes, it is a trapezoid. The legs, the bases are parallel with a slope of 1. All right, then we need to decide if it's isosceles or not. So if it's isosceles, the legs will be congruent to each other, and that means that we can use the distance formula. So the distance between B and C will be the horizontal movement squared plus the movement of vertically squared under the radical. So we've moved from -2 to 0, we've moved 2 units. From 0 to -3, we've moved 3 units. So 2 squared and 3 squared gets us 4 and 9, so square root of 13. That's the distance between B and C. Likewise, between A and D, the horizontal movement from 1 to 4 is 3, and the vertical movement from 3 to 1 is 2. So 3 squared and 2 squared gets us a 9 and 4 again, so a square root of 13. That's the distance between A and D. So yes, it's isosceles as well. All right, next we're asked to find the distance between F and G when segment FG is the mid segment of the trapezoid. So the distance between F and G is not as small as 6.2, it's not as large as 14.6, it's the average. Think of it as a midpoint. When we're finding the midpoint of 2 points, we add the x's and divide by 2, we add the y's and divide by 2. Similar process, only this time we're only using the 2 segments, adding them up and dividing by 2. So 6.2 and 14.6 added together and divided by 2 gets us 20.8 divided by 2, which is 10.4. We also need to be able to work the other way. If we have the mid segment, then we need to be able to find one of the bases. So 24 is what we get when we take x and add it to 16.7 and divide it by 2. Or another way of thinking of this is if we doubled the mid segment and got 48, 48 would be the same thing as x plus 16.7. So solving for x, we subtract 16.7 from both sides. And we're going to get 31.3. So 31.3 is equal to, 31.3 is equal to x. All right. Next, we need to be able to find the endpoints of a mid-segment when we have a trapezoid graphed. So this trapezoid is graphed. We have our parallel lines, our parallel bases are AD and BC, and our legs are AB and CD. We want our mid-segment to be parallel to the bases. So our mid-segment is going to be in here somewhere. And so that means we find the midpoints of the legs. We're finding the midpoint of AB So halfway between 0 and 8, 0, 18, or 0, 8 and 18, 8, the y's did not change, so halfway between 0 and 18 is 9. So these are marked by 2's, 9, 0, 9 would be here. 9, is that right the first time? 9, 0 would be here. Halfway between 1, 4 and 2, 0, if I have 1, 4 and 20, 0, I need to add the two x's together and divide it by 2. Add the two y's together and divide that by 2. And write it as an ordered pair. So 21 halves, and 4 divided by 2 is 2. 21 halves is a 10 and a half. So if this is 10, this would be 11. 10 and a half would be halfway between 10 and 11, so a fourth of the way over and 2 up. There's our other midpoint of our leg, the end point of our mid segment. This third line should now be exactly in the middle and parallel. Okay, so if you are back to the middle and looking at kites, kites have a few special properties, but not nearly as many as trapezoids. A kite is a quadrilateral that has 2 pairs of congruent sides, but the 2 congruent sides are consecutive to each other, not across from each other. So they share an angle. And not all of the sides are congruent, or it would make it a rhombus. So that's our definition of kite. One of the cool things about kites is the diagonals are perpendicular to each other. They form a right angle. If they're not perpendicular, your kite won't fly. It'll flop around or spin, but it will not fly. And the second property of kites is that exactly one pair of opposite angles are congruent. This angle and this angle are congruent, not 2 pairs, just 1 pair. All right, so for our first example of a kite, we're asked to find the value or the measure of angle D. So angle D is one of those 2 congruent angles. It's congruent to angle U. And for all quadrilaterals, the interior angles of convex quadrilaterals add up to 360. So if I add 127 to 37, I get 164, and I take 360 minus 164. And get 196. I have 196 degrees to split evenly between these 2 angles. And so since they're congruent, we're taking 196 and we're dividing that by 2. And each of these angles is 98 degrees. All right, last example. To find the lengths in kites. They want us to find the distance between A and D, and then the perimeter of kite ABCD. So the distance between A and D is this hypotenuse, because we know that kites have to have perpendicular diagonals or they will not fly. And so if I want to find the distance between A and D, I'm going to take 12 squared and 24 squared and take the square root of that, because the Pythagorean theorem says in a right triangle, the leg squared plus the leg squared is the hypotenuse squared. So 12 squared is 144. 24 squared is 576. And when we add those up, we get 720. So the square root of 720 is the distance between A and D. Because it's a kite, the 2 sides that are connected to each other, connected through D or adjacent to each other, are going to be congruent, so 720 for CD. And then we need to find the distance between A and B, or B and C, to find the rest of the perimeter. The perimeter is the distance around. So 6 squared plus 12 squared gets us 36 and 144.
Hey, good morning, Monarch Nation. Mr. Ryan here. Happy
Square root
Friday.
of 180.
Hopefully everybody's had a great week. We appreciate the
Add them up.
energy and enthusiasm this week.